All right, let's take a look at the teammate challenge. And the first table here is, will the solute and solvent be miscible, soluble, insoluble, or immiscible? So first one, we have a solid that we're trying to dissolve in a liquid. A solid is I2, so that would be nonpolar covalent. And I know it's covalent because iodine is a nonmetal, so it's to the right of that zigzag staircase. And there's no greedy atom that's winning here. And then we are trying to dissolve it in liquid benzene. Benzene has no greedy atoms. Nothing is showing up in color like we see down here, the red. So that means that it is also nonpolar covalent. And we know like dissolves like, so this would be soluble. It's a solid that would dissolve in the solvent, as nonpolar dissolves nonpolar. Next, we have liquid bromine. Similar to iodine, it would be nonpolar covalent because we've got two nonmetals. And we already wrote that benzene was nonpolar covalent. We would use a different word here, though, because it's two liquids. So we would use the word miscible. These would be miscible. All right, potassium chloride would be KCl. That would be ionic because it's a metal and a nonmetal, and we can see it forming a crystal lattice. Methanol is all nonmetals, and it has a greedy atom. So this would be polar covalent. And we also learned that ionic things dissolve in polar things as well, so this would be soluble. Methanol is polar. Oops, I don't know why I wrote an N. Polar covalent. It's got that greedy atom, and water, of course, is also polar covalent. This is two liquids, so they would be miscible. And then we've got iodine. Again, we decided this was nonpolar covalent, trying to dissolve in acetic acid, which would be a polar covalent liquid. This solid trying to dissolve in this liquid would be immiscible. Next, it says, draw a picture of how calcium chloride solute would form a solution versus how solid maleic acid would form a solution. You can use a rectangular shape to represent the maleic acid molecules. Okay, so calcium, when it's separated from chlorine, would have a +2 charge, and chlorine would have a -1 charge. And oxygens have a partial negative, so the oxygens in water would pull the positively charged calcium ions away from the chloride ions, and then the hydrogen, partially positive charged hydrogens, would point toward and surround the chloride ions. So in solution, both of these would be surrounded. Okay, in contrast, maleic acid would maybe have a bunch of these together, but then they would have some breaking off with water molecules kind of surrounding them. And so even though you've got one separating away from the others, they're not breaking bonds within the maleic acid. The spectrophotometer allows us to use Beer's law to determine the relationship between concentration and absorbance of light. So let's say we had to calculate using this formula, the mystery concentration. The slope is K, so that's 20,000. It says the absorbance is 1.15. And since C is our mystery, we need to divide both sides by 20,000 to solve for the mystery concentration. So we've got 1.15 divided by 20,000. This would be a concentration of 0.0000058 molarity. Okay, now let's look at some data. Let's say you've got a set of standards here and you measured their absorbance, and this is of red dye in Hawaiian Punch. We've got to graph this into Microsoft Excel. Let's see here. So we've got solution concentration, absorbance, solution concentration, absorbance, solution concentration, absorbance, solution concentration, absorbance, and solution concentration, absorbance. So I'm going to highlight the data and I'm going to insert a scatter plot, and I am going to add a trend line, and I'm going to display the equation so that I can see the slope. It is 27,500. Okay. Oops, go back to this. Slope equals 27,500. So absorbance equals slope times concentration. We want to solve for an unknown. What if the absorbance was 1.43, which would be about right here? So I would predict it would be close to 0.00005. Slope is 27,500. I'm almost done. And then times concentration. Divide both sides by 27,500 to get your final answer here. So I'm going to go to my calculator, 1.43 divided by 27,500. The mystery concentration, just like I predicted, would be about 0.000052. All right, there we go.